Namaste. By considering the request from the Tamil Nadu students, this unit onwards, we are dealing the classes mainly in English medium. I think for our repeated student there is no problem regarding the same. Okay, so directly entering to the question. Today we are going to discuss two chapters. One is redox reaction and other is hydrogen water and hydrogen peroxide. From redox reaction only 8 questions and remaining question from hydrogen water hydrogen peroxide. Redox reaction is actually a continuation. It's not only present in the first year. There is a continuation in the second year also. Name of the chapter is electrochemistry. Okay, so directly going to the question. First question, oxidation number of hydrogen is -1 in options SiH4, RBH and LiAlH4, lithium aluminum hydride. See, SiH4 hydrogen is in +1 state. Okay, RBH, rubidium, first group, second group elements when joined with the hydrogen, first group +1, second group +2. So in these cases normally hydrogen is in -1 state. So option B, number 2, second option is correct. Lithium aluminum hydride, the name is hydride. The spelling ID normally represent negative ion, chloride, bromide. Okay, so that compound also contain H in -1 state. So two options were correct. So answer is correct. Fourth option 2 and 3. Second question, oxidation number of an element X +3, Y -1. Then the formula of the compound. So by combining X and Y, there are 4 options given and you have to identify the correct formula. The logic behind it is, when we are finding the algebraic sum of the oxidation numbers, it should be 0 if the formula is correct. Okay, let us try first option. X3Y is the first option. X3Y. X3Y. I told you what is oxidation number of X +3 and Y is -1. X is +3, Y is -1 means 3 into 3 plus 9 -1. It never be 0. So that is not our answer. Second question, X2Y also not possible. Third one is correct, XY3. XY3 means X +3 and Y -1 means +3 -3 equal to 0. So the right formula option 3. Next, oxidation number of iodine least. First option I2 is 0. Elemental form oxidation number 0. KiO3. K plus X, we don't know the oxidation number of iodine, so I am giving it as X. Then -2 for 3 oxygen -6. So algebraic sum is equal to 0. So iodine is in +5 state. That is the highest as per the given options. Not the highest +5. +7 is also possible for halogen. PbI2, that is answer. Why? Because Pb2 plus I minus. -1 is the lowest oxidation number. And the fourth option, there is a correction. It is not Ni3, Ki3. Okay, there is a concept regarding nitrogen. Nitrogen trihalides only NF3 is known to exist. So that is a printing error, Ki3, K plus I3 minus. K plus I3 minus. So altogether 3 iodine atoms have -1. So one iodine has -1/3. -1/3 and -1. -1/3 and -1. So answer not I2, PbI2, Ki3. Okay, iodine is in -1/3 state. Okay, so that fourth one is the right answer. Next one, disproportionation. I think you know the meaning of disproportionation. Disproportionation means the same atom undergo oxidation and reduction. Simultaneous oxidation and reduction happening for the same atom, not different atoms of the same molecule. That is called decomposition. Intra-redox reaction, that is another name. But disproportionation strictly indicate the same atom undergo change in oxidation number. First option is right. Why? Because hydrogen peroxide decomposition is a perfect example of disproportionation. Then P4 plus in basic medium, that is providing pH3 and H2PO2 minus. You can verify the oxidation number of phosphorus. It is increasing and decreasing. Third option also, sulfur oxidation number is increasing and decreasing. So all these represent disproportionation. These 3 equations are exactly given as per NCERT. Okay, they are strictly followed by NCRT, these equations. Okay. Next question number 5, the number of moles of the electrons involved when 1 mole of KMnO4 react with a reducing agent in basic medium. Basic medium is a specification. See, KMnO4 can act as an oxidizing agent in acidic medium, basic medium, as well as in neutral medium. Neutral medium, rarely they are asking question. Acidic medium and basic medium, that is frequent. In acidic medium, you know what happened? Acidic medium, MnO4 minus, you try to by heart, MnO4 minus, in acidic medium it is changing to Mn2 plus. In basic medium as well as in neutral medium, MnO4 minus is normally changing to Mn4 plus. You know the oxidation number of Mn plus 7. If you have any confusion, you can verify whether it is plus 7 or not. See, plus 7 is changing to plus 2 means by adding 5 mole of electron. Agree? Plus 7 is changing to plus 4 by adding 3 moles of electron. This 5 is called valency. Here 3 is the valency. Agree? That is an additional information. The question, how many electrons involved when 1 mole of KMnO4 react with an reducing agent, means it undergo reduction. Agree? In basic medium. So how many moles in basic medium? 3 mole. Actually that is also called valency. Suppose you are asked to find what is the equivalent weight of MnO4 minus in this particular equation. Okay, you know equivalent weight, molecular weight by valency. If M is the molecular weight, I am not adding the weights of MnO4 etc. Total, what is, suppose M is the molecular weight, 3 is the valency, then M by 3 is the equivalent weight. Equivalent weight is M by 3. Here it is M by 5. Agree? So answer 3 means option 1. Next, number of moles of Fe2 plus oxidized by 1 mole of KMnO4 in acidic medium. Okay, you know what happened to Fe2 plus? Fe2 plus, when we are oxidizing, it will be changed to Fe3 plus. Fe2 plus normally changing to Fe3 plus. You know, Fe2 plus become Fe3 plus by losing 1 electron. This number of moles of electron lost is also called valency. In the case of oxidizing agent, valency is the number of moles of electron added. In the case of reducing agent, valency is the number of moles of electrons lost. Then I will give a short form. There are so many short forms with us. We are giving only some of them. See, MnO4 minus, as per the discussion, valency 5 in acidic medium. Fe2 plus, as per this discussion, valency is 1. So when we are cross multiplying, the meaning is 1 mole of MnO4 minus can combine with 5 moles of Fe2 plus. Agree? Okay. So now the question is, number of moles of Fe2 plus oxidized by 1 mole of KMnO4, answer is 5. Suppose the question is reversed, 1 mole of Fe2 plus need how many moles of MnO4 minus, answer is 1 by 5. I am going to balance this equation also. Simple step, balancing this equation. Listen here carefully. 1 mole require 5 mole means MnO4 minus plus 5 Fe2 plus gives, I am giving a space, leaving a space. MnO4 minus is normally changed to Mn2 plus in acidic medium, that we already explained. Fe2 plus, that is changing to Fe3 plus. So almost it is completed. Then 2 more steps remaining. 2 more steps left behind. 1. How many oxygen on left side? 4 oxygen. Number of oxygen atoms are normally balanced by adding equal number of water. So on right side I am adding 4 molecules of water. So the problem regarding oxygen is solved. But there is another problem arises. When we are adding water, number of hydrogen atom become excess. How many hydrogen in that side, right side? 4H2 means 8H. Since the reactor is conducting in acid medium, you have to balance the number of hydrogen by adding H plus. So balancing is complete. So there is a method of balancing the reactions based on oxidation number. This is our method. Okay. If you are thorough with any other method that you studied in your organization, your school, follow it, no problem. Anyway, final answer will be the common one. Same. Agree. So that question is over. Moving to the next one. Going to the next question. Listen carefully. Listen carefully. Yes, exactly the same question. For a reaction Fe2 plus MnO4 minus plus H plus Fe3 plus Mn2 plus set by to H2O, you are asked to find X and Y. X means number of Fe2 plus 5 and Y is 1. So 5 and 1, answer 3. So looking at the previous explanation, you can answer the next question, question number 7. Okay, question number 8. MnO4 minus plus Br minus gives MnO2 plus BrO3 minus in basic medium. The number of moles of BrO3 minus in the balanced equation. We can verify it. MnO4 minus plus Br minus. MnO4 minus plus Br minus gives MnO2 plus BrO3 minus is the equation given, and you are asked to find the number of BrO3 minus in the balanced equation. The number of BrO3 minus in the balanced equation. See, Mn oxidation number plus 7 and here Mn oxidation number plus 4 means the change in oxidation number is 3. Br minus 1 and in BrO3 minus Br have oxidation number plus 5. So minus 1 plus 5 difference is 6. Okay. So you can verify 3 and 6 that can be simplified as 1 and 2. That means 1 mole of Br minus can react with 2 moles of MnO4 minus. If Br minus is 1 mole, number of BrO3 minus formed is also 1 mole. So answer 1 mole. Agree? Okay, this 2, that is the difference in the oxidation number of bromine, that should be multiplied by the other equation, and the change in oxidation number of this equation, that is multiplied by Br equation. Br minus gives BrO3 minus. Just cross multiplication. The same thing happened here also. Okay, oxidation reaction is multiplied by the change in oxidation number of the reduction reaction. Reduction reaction is multiplied by the change in oxidation number of the oxidation reaction. That is the meaning of cross multiplication. So answer 1. So that's all. I am extending this question one more. Suppose we want to balance it. Let us balance this reaction in basic medium. So 2 MnO4 minus plus Br minus gives 2 MnO2 plus BrO3 minus is the equation. Now let us balance the number of oxygen. 8 oxygen on left side, 4 plus 3, 7 oxygen. 8 oxygen left side, 2 into 2, 4, 4 plus 3, 7 oxygen means 1 oxygen is deficient on that side. So that deficiency is balanced by adding water. So oxygen is solved, but after adding 1 molecule of water, 1 mole of water, there are in excess of 2 mole of hydrogen. So how to balance hydrogen in basic medium, you know? Add 2 water here. Actually you are requested to add 2 hydrogen, but unfortunately you are not able to add hydrogen since the reaction is conducting in basic medium. Sorry, since yes, the reaction is conducting in basic medium. If it is acidic medium, okay, no problem, you can directly add H plus. Since it is in basic medium, there is no chance for adding H plus. Okay, so the method, add equal number of water to the hydrogen deficient side and an equal number of OH minus on the opposite side. You know, when we are adding 2 water, actually it means 2 H plus plus 2 OH minus, and to the opposite side you are adding 2 OH minus means you are cancelling OH minus. So effectively hidden there are 2 H plus. Then after that you can add, you can not add, you can cancel 1 water. Agree? So the real balanced equation is 2 MnO4 minus plus Br minus plus H2O gives 2 MnO2 plus BrO3 minus plus 2 OH minus. That is the balanced equation. Okay, so that's all regarding redox reaction. Now question number 9 regarding hydrogen. Hydrogen, water, hydrogen peroxide, 3 different headings were there in that chapter. See, first question of hydrogen, that means question number 9. Tritium is radioactive. What is its half-life period? Exactly given in NCERT. You know, hydrogen isotopes, protium, deuterium, tritium. Tritium is radioactive. Its half-life is 12.33 years. That is given in NCERT. Option 4. There is a reaction given CO plus H2O gives CO2 plus H2. Carbon monoxide plus steam, H2O suffix gas is there, steam gives catalyst is the high temperature CO2 plus H2. This reaction is known as, that reaction is called water gas shift reaction. Water gas shift reaction. Carbon monoxide is oxidized to carbon dioxide. Actually, not only carbon monoxide. Water gas means carbon monoxide plus hydrogen is there. Okay, when it is again reacted with a steam, excess steam in presence of a catalyst, CO is oxidized to CO2. That change is called water gas shift reaction. Number 2 option. Hydrate gap, Hydrate means the binary compound formed by hydrogen by combining with any element of the periodic table. Binary, only 2. See, in the periodic table, actually, maximum number of compounds are created by hydrogen. It's not carbon. When we are learning organic chemistry, most of the organic chemistry teachers are saying that maximum number of compounds are formed by carbon. That is right to a definite extent. But when we are comparing the number of compounds, it is more for hydrogen, because hydrogen can combine with every element of the periodic table except 18th group. 18th groups they are called noble gases or inert gases. They are not having any capacity to combine with any other atom. Fluorine and oxygen exceptions were there, XeF2, XeOF2, like that. Okay, so exception 18th group, when we are comparing the rest of the part of the periodic table, most of the elements can combine with the hydrogen, but an exception, group number 7, 8, 9. Group number 7, 8, 9, okay, cannot combine with the hydrogen. Group number 7, 8, 9. So that area is particularly called as hydrate gap in the periodic table. Option 4 is the correct answer. Okay, hydrate, there are 3 types of hydrate: ionic hydrate, covalent hydrate, interstitial hydrate. Ionic hydrate formed by S block. Okay, all the properties of ionic compounds are applicable here also. P block form hydrate, that is called covalent hydrate, and that include 3 different types: electron deficient, electron precise, electron rich. Group number 13 form electron deficient, group number 14 form electron precise, 15, 16, 17 can form electron rich hydrate. So that is the description regarding P block hydrate. And D and F block can form hydrate, and that is called interstitial hydrate, and actually that is formed by incorporating hydrogen in the interstitial position of the crystal lattice, and that occupancy is called occlusion. Maybe you are aware with it. So answer 4, that is discussed. Question number 12. Among the following, the electron precise hydrate, just now I explained, electron precise means exactly completing octet, it is GeH4. First option is B2H6, it is a dimer of BS3, it is electron deficient. NS3 electron rich, water is also electron rich because in NS3 nitrogen has a lone pair, in water oxygen has 2 lone pair. After completing octet, there is a pair of electrons called lone pair. Presence of lone pair is the identity of electron rich hydrate. So GH4, exactly octet is completed. Question number 13, basic principle of hydrogen economy. That is I think the last area of the chapter, NCERT, as per NCERT, there is a heading called hydrogen economy, and it is given in italics also. Transportation and storage of energy in the form of liquid or gaseous hydrogen is technically called as hydrogen economy. I am saying the exact same sentence given by NCERT. Okay, so option 4 is the sentence given as per NCERT. 14th question, hydrate of nitrogen that is distinctly acidic hydrate. They are given options NH3, N2H4, N3H, N2H2. HN3 or N3H is called hydrazoic acid, and that compound is distinctly acidic. HN3, hydrazoic acid. It is not ammonia, HN3. Agree. Next, you are learning the same compound in P block of 15th group, second year P block of 15th group, regarding the preparation of pure form of hydrogen, decomposing an azide, and that azide is actually the salt of hydrazoic acid. Absorption of hydrogen by palladium or platinum is called, just now I explained the same term, occlusion. Question number 15, option 1. Question number 16, in Clerk process, hardness of water is simply because of the presence of Ca2 plus or Mg2 plus ions present in dissolved form as salt. Salt may be bicarbonate, chloride or sulfate. Okay, if the hardness is executed by bicarbonate of calcium or magnesium, that is called temporary hardness. If it is executed by the sulfate or chloride, it is called permanent hardness. Temporary hardness can be removed by boiling. Okay, second method is Clerk process, by adding calculated quantity of lime. Lime means calcium hydroxide. So that procedure is called Clerk's process. The question, Clerk's process, hard water is treated with lime, calculated amount of lime. Exactly the same sentence is given. Option number 1. Calculated means does not exceed, because you are adding calcium hydroxide. Hardness is actually created by salt of calcium or magnesium. Okay, to remove that calcium or magnesium salt in the dissolved form from water, we are adding lime, means again calcium hydroxide. So don't exceed the quantity of calcium hydroxide. If you are exceeding the amount, again Ca2 plus ions will present in water. Agree? So that is again contributing hardness. That is the word meaning calculated by using the principle of titration. Exhausted permuted, you know permuted method by using zeolite. Aluminium silicates, sodium or potassium aluminiums, Na2, Al2, Si2, O8, N times water. This is the formula given by NCERT. This frame is called a zeolite. This is only meant for balancing the charge. It is actually a silica. Silica means SiO2. It's a 3D network structure. Okay, and from the 3D network structure of SiO2, we are replacing some of the silicon atom and substituting aluminum. That is why it is called aluminosilicate. Okay, naturally occurring aluminosilicates are available, but nowadays we are synthesizing artificially also. Okay, Pune NCL, you know, National Chemical Laboratory, one of the famous chemistry research institutions all over the world. It is Pune. Okay, they are developing new type of zeolites because it is used as a catalyst nowadays. Anyway, zeolite, okay, it is packed in a tower, and when we are pouring hard water means may contain calcium chloride or magnesium sulfate, anything. So this Ca2 plus or Mg2 plus ions are exchanged with the sodium. So you are getting, when we are pouring hard water, okay, it is free from hardness, but unfortunately the zeolite become calcium zeolite or magnesium zeolite instead of sodium zeolite. So how will you regenerate that calcium or magnesium zeolite? Originally means we have to add a saturated solution of NaCl. Agree? So that will be the answer. Exhausted permutates regenerated by the treatment with the NaCl. Okay, simple logic. Originally it was sodium zeolite, and when we are pouring hard water, it becomes calcium or magnesium zeolite. So it should be regenerated by adding NaCl, saturated solution of NaCl. That is answer. Next, question number 18. Industrial preparation of H2O2 involves auto-oxidation of 2-alkyl anthraquinol. 2-alkyl anthraquinol, that is given in NCERT. Okay, 2-ethyl anthraquinol. When we are oxidizing atmosphere, it becomes 2-ethyl anthraquinone plus H2O. Okay, 2-ethyl anthraquinone. You know the structure? Okay, OH, ET. When it is treated with the air, that is sufficient. It becomes I am writing or heat is there plus H2O2. That is a reaction. Actually, this H2O2 is only 1%. First of all, you have to extract it with water, then distilled. Okay, first it is distilled under reduced pressure. Okay, and finally you have to remove the last traces. That is also present as a question. The last trace of water, 1% H2O2 you have to extract with water, means you just add water, shake it and take it out. This compound never dissolve in water. It's a heavy organic molecule. How it is possible to dissolve in water? So water will be capturing hydrogen peroxide. So you are getting hydrogen peroxide in water as 1%. Okay, and that is changed to 60% by distillation. Clear? Then again up to 9, some data are given in NCERT. Anyway, the last traces of water present in that mixture is removed by crystallization. Okay, that logic is asked so many times in examinations. Okay, remaining traces of the last traces of water in hydrogen peroxide, that is removed by crystallization. So that is present as the next question, question number 19. Last trace of water in hydrogen peroxide is removed by answer is freezing. Crystallization, there is no word used, freezing. When we are cooling it, okay, water will crystallize out as ice. Okay, H2O to remain as such. So question number 18 and 19 that we discussed, and then number 20 that asks question, perhydrol is actually a solution of hydrogen peroxide that is used as an antiseptic. Its concentration is given, it is 30 volume strength. Volume strength I am explaining. H2O2 is an unstable compound, normally it undergo decomposition. H2O2 gives to H2O plus O2. So volume of oxygen gas liberated from unit volume of H2O2 at STP. Volume of oxygen gas, this is gas and this is liquid. Okay, so from unit volume of hydrogen peroxide, how much volume of O2 is liberated at STP? That volume of O2 is recorded as volume strength. As per the given option 30 Vs, first option 30 Vs means from 1 ml of H2O2 you are getting 30 ml of oxygen at STP. From 1 liter of H2O2 30 liters of oxygen that is generated. So 100 volume strength, 100 Vs, normally we are using 100 Vs also. 100 Vs, what is it? From 1 ml of H2O2 you are getting 100 ml of oxygen. Is it possible? It's possible. That is why I asked. Okay, this is a liquid and this is a gaseous compound. So it's possible. So that's all about the 20 questions from the 2 chapters of first year, redox reaction and hydrogen. So that's all. Okay. So from this session onwards, we are discussing the questions in English. Okay. That is helping the students of Tamil Nadu. They are asking. Okay. So that's all. Study well. Prepare the brief sketch of this question. Okay. There is no problem, only answers. So write the answer key and submit. Clear? If you have any sorts of difficulty or doubts in any question, contact me. Okay. So that's all. Namaste.